10.3, obviously, the sample exercise. So we're going to take a look at this example just so that we're all on the same page. Let me read what we have at the top here. Suppose we have a gas confined to a cylinder. Cylinder is shown in figure 10.12. Consider the following changes. So this is part A now. It says, heat the gas from 298 K to 360 K while maintaining the piston in the position shown in the drawing. Okay, so the question is, what happens to pressure, volume, number of moles, and temperature? So what we know from this, of course, is that when we're heating, our temperature, there we go, there it goes, is going up. The number of moles is not changing, and it actually says the piston doesn't change either, which means that the volume stays the same. Okay, so what happens when we have pressure versus temperature? If you increase the temperature of a fixed gas, what happens to the pressure? And it looks like the pressure is going to go up. Okay, just to review very quickly, we have these four: pressure, volume, number of moles or number of particles, which is the same thing, and temperature. If I'm talking about pressure and temperature, that relationship is described in a law called Gay-Lussac's law. Okay? That is Gay-Lussac's law. If we're talking about pressure and volume, that would be Boyle's law. If we're talking about volume and temperature, that would be Charles' law. I think in the book, if you look this problem up, in the book it says that this is Charles' law, but it's clearly not because volume is not changing. So if volume's constant, then it can't be Charles' law because Charles' law is volume and temperature. And if we have volume and number of moles, then we have Avogadro's law. Actually, it's a hypothesis. I'll just call it hype. So there's our first one. So when temperature goes up, pressure goes up. That's what we're looking for as far as talking about the number of the different changes. This says move the piston to reduce the volume of gas from 1 liter to half a liter. So if volume goes down, now here I'm going to check to see what it says about density. This says the gas is compressed at a constant temperature. So that means that, according to this, temperature does not change. We're not changing the number of moles. That means pressure goes up. This would, of course, be Boyle's law. Okay, because pressure and pressure and volume. When we have pressure and volume, if pressure goes up, volume goes down. It's inverse. We have our first, an inverse relationship. All the rest of them, as far as Charles, is direct. With one goes up, the other one goes up. That says direct. Avogadro's hypothesis is direct. With one goes up, the other one goes up. And Gay-Lussac's is also direct. Let's see what we got for the last one. So the last one says inject additional gas, which means that my number of molecules is going up, the pressure of the gas, and the number of moles of gas present in the cylinder. Okay, so let's just check to see if this is something that stays at constant temperature. It says additional gas is added at a constant volume container. Okay, so it's constant volume. Now we don't know about the temperature, but we do know that the volume doesn't change. And if you have a rigid structure and you add gas to it, of course the pressure is going to go up. And we're not sure about the temperature either, but here's what we do know. Distance, average distance, that's AVG, average distance between molecules, we know that goes down like that. So average distance of molecules decreases when pressure goes up and we add molecules. Now let's take a look at what we got for, it says what happens in the density of a gas. It says the density, well first of all, here's what we know. Density of a gas is the mass of the gas divided by the volume of the gas. If we have a constant volume container like this, but it says the gas is heated. So if this doesn't change and we're not adding or subtracting molecules, then nothing changes. That means there's no change here for density. No change for density because we're not changing the mass or we're changing the volume. This says constant volume, which means that the volume doesn't change. The gas is compressed at a constant temperature. So now the temperature's not changing. Okay, but one of our parts is changing. If we're compressing, that means we're decreasing the volume. If volume goes down, then what happens to density? That's my question. What happens to density? Does it increase or decrease? When you decrease, say you have something like 2 over 4, and I decrease the bottom number by 1, 2 over 3, which number is bigger? Okay, obviously the 2/3 is bigger than the 2/4. So that means that density actually increases when we decrease the volume. Density of the gas increases. Here's the additional gas is added to a constant volume container. So now we're density equals mass divided by volume. If it's constant volume, that's not changing, but the mass is because we're adding additional molecules. And if we increase the if we increase the mass, what happens to the density? Well, if you increase the numerator, then of course the whole number increases also. So that's going to be an increase of density of the gas. All right, that's it. Nice, quick, easy assignment.